Hello everyone. Please someone confirm if I am audible and the screen is visible.
Yes, you are audible and the screen is visible.
So hi, I am Harsh Kumar Khatri. I am an MSP from India and today I'll be talking about Pi and AI in Kota and introduction to ML and AI. Before starting the event, let's look at a video which Andrew has for all of you. Just a second.
Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There is never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood, so I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, and that's really important work. Well, it's nice chatting, and now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
So this was the video. Basically, if you were not able to hear about the sound, let me tell you about the video. This in this video, Andrew basically tells all of us, and he greets us from different people of the of his team, which is a deep learning AI team. He goes and talks them about what they have to offer to the community and what people are learning being a part of the community. And he also talks us about the event Pioneer event, which is an event organized by the people of various different cities to learn, to meet new people, to learn more about AI, ML, and different fields related to artificial intelligence. So, first of all, let me introduce myself again. I am Harsh Kumar Khatri. I am from Kota, Rajasthan. So, that is why the event theme is Pi and AI Kota. And the topic for today is Introduction to ML. Let's begin with the contents what we will be covering today. We'll be covering about ML applications, ML in daily life, skills which are required to be an person practicing ML, deep learning, AI, data science, and many more. About ML types of machine learning models which are there, machine learning algorithm, which are steps which are involved, and we'll be getting seeing how one can get into ML. Let me tell you that I have also started practicing ML uh, from past 4 months, I can say, and I have learned very much through different courses and various different sources which are available online. So let's begin with the application which are there for ML. The first one is dynamic airplane pricing. Most of you have seen whenever you go to book a ticket or book something, when you keep on visiting that site again and again, there are chances that the price when you visit the site second time or the third time, the prices of the tickets are raised. So that is a application of machine learning. Customized content for every user. All of you have used YouTube in some or the other way. You have seen that the video which are appeared on your home screen are always different from others. These are given to us, or we can say these are in our feeds only because of the videos we have watched of the same type. Also targeted ads for targeted customer. Different ads are being run. You can see the profiles of Facebook, profiles of different people. All of you might not get same ad. You will be, if someone has searched about a particular product on Amazon, he will be seeing the ad of that product, and someone who has seen a product on Mintra, he will be seeing an ad for that product. Now talking about the first application, airline companies are using machine learning algorithm to analyze various factors. Some of the factors which are listed here are time of the booking. They are seeing at what time the person is booking the ticket and then changing the price accordingly. Seeing how in the demand the flight is. If the flight is in much more demand, the prices are raised automatically every time you visit the uh, ticket price or the ticket list booking center. Number of user which are checking the price concurrently, or currently we can say, the departure time, destination, and the season. For example, we can see the places which are generally cold, like in India there is Shimla. The prices for the tickets for that place are raised in the season of summer, and the places which are hot, like Rajasthan, the prices for them are dropped in the summer season. So that is also due to AI. The people practicing backend, or the model which are there backend, they keep on seeing and detecting the price automatically and generate the dynamic ticket price which you will be willing to pay at that moment, and then it will be showing you the price accordingly. Now customized content for every user. Companies like Twitter, Instagram, and Facebook are using ML to make their social media platform addictive for user. You will filled with content which you might like and spend more time on this platform. So you have seen, if someone of you is willing to see the content related to gymming or bodybuilding, when you go on the explore feed, you will be seeing more of the content which is related to these specific tags. But if someone is there who is willing to see the beauty content, or of the comedy content or comedy sketches, he will be seeing much more of that type of content in the explore section. And you can also see that on the YouTube or different social media platform which are listed here. Next is the targeted ads for targeted customer. Now once you have get addicted to this platform which were mentioned in the previous slide, they start acquiring and using your information like behavior, what product content you are spending most time on, demographic, what is your age of your customer, psychographic, information about a person's value, attitude, interest and personality traits, geographic, where is the customer from, to get to know about more about you and generate targeted ads on your social media platforms or the platforms which are using, so that you go visit that product much and much more, and you buy that product from that targeted ads. Now we can see that how ML is useful in our daily life. All of us must have done Amazon shopping from Amazon or any other social media no e-commerce site we can say. We have all used Google Mail. Some of you might have used Outlook Mail or any other mail, but it is present in all of the mails. All of us use Google Maps for seeing the different locations or the maps. We use Google Translate if we visit some of the places where the people of that place are don't know our language. Most of you have used Amazon Alexa also, which is also a good example of machine learning we use in our daily life. We can say here, how do you think that Amazon recommends you the product? Amazon recommends you product on the basis of your previous things which you have seen or bought, and on the basis of that only it recommends you different products. You can see every time you visit a product, it has people who bought this product also bought listed below, so you can find from that products and see different product there. Now you can also see here how do you think that Google predicts the traffic so accurately? Google predict that traffic on the basis of different people visiting the same location or the same road at the same time on various different days. On the basis of that, ML models work and predict the traffic or the location time which you will be taking to reach. On the basis of that, real life two more examples are also there, that how do you think Google Translate converts the text for you? There are very big models which are running on cloud. These are the models which are trained continuously on millions and millions of data sets, and then they are being deployed on the different apps, like here is the Google Camera app, through which you can click the photo of any other language and that will be translated into the language which you want. Now, Amazon Alexa is also a good example. How do you think Amazon Alexa responds to your command? You might have seen an ad on the TV which says that Amazon Alexa is now being sold in different cities on the basis of the languages which the people speak in that city. Like in India, it is being coming in the Hindi language also. Earlier, it was only for the English language. So it is being trained on the different data sets of people. For example, South people have different accent, the people from North have different accent. It is being trained on different accents so that people from all the section, or we can say all the cities, are able to communicate with the device efficiently. Now we will see which are the skills required for a data science or ML jobs which are there. You can see for a data analysis, the green one are the skills which are need to be there for a person to be a data analyst. And business intelligence is also required. You can see, you can take a screenshot and read it afterwards, as it will be difficult for me to explain each and everything. So these are all the skills which are required for one to be a data scientist, data architect, data engineer, and so on. Now there are some of the myths which are there in the market, and these myths are myths like that people who are having machine learning or who are practicing machine learning, they will have to lose their jobs afterwards when they have machines working for them. Like you must have read somewhere on or other that a machine will be replacing humans in the coming time. So that is one of the biggest myths that is around the machine learning. Another myth which people generally tell you, or the people who have less knowledge about machine learning tell you, that you should always focus on algorithm. Like if you want to practice to predict a data, I'll be talking about algorithm further in slides, but for example, if you want to predict a price of a house, you always use linear regression algorithm, or always use a scalar vector algorithm, or any other algorithm like the decision tree algorithm. SVM you can use, but it is not true. Or everything revolves around data. If you have a data, sorted data and good amount of data, you can say you can always get the result which you want, or the prediction which you want at the 100% accuracy you can say. But it is generally not possible to get 100% accuracy on the real world data set, but you can get a very good accuracy on that. Now most of the people generally confuse between machine learning, artificial intelligence, deep learning and data science. They generally find everything to be same. Let's clear this myth also. You can see here that machine learning is a subset of artificial intelligence which give a machine the ability to use the stats model to learn from data. Whereas artificial intelligence is the area of computer science that emphasizes on the creation of intelligent machines that work and react like humans. Now, what is the difference between AI and machine learning? AI is the basic, we can say the basic category which holds different categories related, and machine learning is one of the part of them. Now, what is deep learning? It is another subset of machine learning concerned with algorithm inspired by structure and function of the brain called artificial neural networks. Basically, deep learning is based on the neural network, which are there are different neurons which we choose on the basis of the input and the output. For example, if you want yes or no as output, you will be having two neurons on the output corner, and if you have data to be inputted various columns like name, birth date, mobile number, then you will be having three neurons in the input. In both of these input and output, you have different layers or the hidden layers you can say, and these are the layers which are most important for training a neural network. Now looking forward to data science, what is it? Data science is not exactly a subset of ML, but it uses ML and DL to gain insight from both structured and unstructured data. So it is a some amount of part of machine learning and some of the deep learning. And for data science, you need to have a very good knowledge about how to study data, how to predict things out. Now, seeing what is machine learning. Machine learning is a science of programming computers to learn from data. Now, if we look at the technical definition given by Arthur Samuel in 1959, it says that machine learning is a field of study that gives computer the ability to learn without being explicitly programmed. What does this definition tells, or what do we get after reading this definition? It basically says that it is an ability which is given to machine through which they can learn from data, and they can give us the different outputs which we want or which we are willing to get. Now, another definition given by Tom Mitchell in 1997 says that a computer program is set to learn from experience E with respect to some task T, and some performance measure P if its performance on T as measured by P improves with experience E. Now, what does this definition tells us? That a computer program will be learning from an experience, and then will be giving us different output measures in the form on the task T, and we will be getting different outputs on different inputs which we are providing. Now, for an ordinary human to understand what is machine learning, let's see what is machine learning in layman's language. It is a subset of AI which gives a machine the ability to use the stat model to learn from data. We will be providing input in a model or in a machine learning model which we there, and we will be getting output which is the predicted result that machine will be providing us. What is the difference between traditional programming versus machine learning? You can consider traditional programming as you are given a data and you are given a role. In mathematics, there is generally y equals to a plus b or y equals to a into 3. You are given data set what will be the value of a, and you will be getting the value of y accordingly. But the main difference which machine learning brings is that machine has the rule. We can provide a rule to machine, and we will keep on giving inputs regularly, and machine will be giving us the answers according to the rule which we have fed in it. Like here in the image, it is shown that the rule is y equals to a into 3. If we have trained the machine according to the some data set, and we will next be giving a equals to 3, then it will be providing us the y value as 9. So basically we will be getting predicted values through the machine. Now, what are the uses of machine learning? We can use basically machine learning in four different concepts. The first one is problem requiring lot of human work and tuning. If there is some problem which is there from pre-existing times, and humans take a lot of amount to calculate the result or predict the output, or tuning is required for humans, then we can basically give that work to machines, and they will be doing that work in the in good amount of time, or we can say small amount of time, and we will be getting the predicted output accordingly. Next, we can use machine learning for complex problem having no good solution. There are many problems in mathematics which still don't have a good solution or the good output. Then we can provide that problems to machines, and we will be getting an output accordingly. You might have heard that a computer from Google or Facebook, I'm confused between both, it was given a problem and it had solved it in minutes or seconds, and the scientists were taking it month to solve. So there can we can use machine learning when the environments are fluctuating, like there are data set which are differing on the basis of seasons or on the basis of months. We can basically provide that to machine learning models, and it will be performing on the basis of different data set which we are providing. It will be providing us different results accordingly. The fourth and the last one is getting insights about new and varying data. As I already told you, data keeps on changing regularly, so we can use machine learning models there and get insights about the new and varying data. Now, usage of machine learning, you can see machine learning is present in most of the field which you are exploring today. For a person who is a teenager, or for the person who is from the 21st century, you will find machine learning in each and every sector you visit. You can see here from travel to marketing to healthcare, social media, sales, automation, credit and insurance. You will find machine learning um, in every sector, and it is predicted that in around year 20 to 24 to 2025, machine learning, you will be finding machines learning all around yourself. Like you can find them in various different things which you are practicing or you are having in those years, coming years. Now we will be seeing what are the different types of machine learnings. There are basically four, but the last one which is there is a combination of two, so I have skipped that. I'll be talking about that in last. Look at these three which are most important ones. The first one is supervised learning, the second one is the unsupervised learning, and third one is the reinforcement learning. Now, the first use case which we will be talking about is email and news segregation. As I have already given you the example of the mails which you all might have used, that is Google Mails or Outlook mails. You all have seen that the mails are always marked as spam according automatically. We don't have to go into the mail, read them, and mark them as spam. That is done accordingly. And why that is done automatically? This is because of the data set which are there pre-built, and the models are trained according to the data set. There are different characters which are there, which are present in the spam mails, and the data set for that characters is very huge, and the models are trained on the basis of that. For let us look when there are no more pre-trained model, then what there might be the case. So if there are no pre-trained model, a human must have to go into each and every mail. He has to see that if this mail is spam or not, then he has to move the mail to the spam folder. But now we can say that the mails are directly moved to the spam folder, and it is also the case that if the sender tries to change the characters from the mails, like if there is a spam mail saying hello I am XYZ, and in the next mail he can say hey you are XYZ. If the mail seems to be a spam to the person sending to the model which is there, then it will be automatically marked as email. This use case is a part of a supervised learning. A news email classification is an example of supervised machine learning task, since a labeled datasets containing text document and their labels is used to train a classifier. A classifier is basically a model which is trained on a large amount of dataset. Now, why this is a problem of supervised learning? Supervised learning is a type of learning in which the model is trained on the basis of label. Like we have certain list of characters which are already present in the spam mails, and we have trained the model according to that character. If this character is present, or this line is present, then this will be a spam mail, and if this line is missing, then it will not be a spam mail. Similarly, we have different sections in our mail, like promotion, social. According to this characters or the different data set which are present, the model classifies them accordingly. Now, what basically supervised learning is? Label dataset training is fed to a model. Once the model is trained, it can be used to predict the label of the new data, test data. Now here you can see different images of apple are given. The first one is red, then light red, dark red, green, and shiny green. You can see here that we have provided a label to all of the images, that these are all images are labeled. We have fed that into algorithm. The data set is fed into algorithm, that is then processed, and it is sent to testing, like and then another input which is a green different color apple, which is fed into the final model. The machine identifies that is an apple. Basically we have labeled this data and the machine is learning from labeled data, so that is why we called it as supervised learning. Now another use case for supervised learning can be that we have aircon, we have different features, and there are different cars. When we feed the model on different types of feature and we have to predict the prices of the car, we can use this case, the case of supervised learning. Now looking at another use case, which is customer segmentation. Have you ever thought how the customers are automatically segmented? Customer You can read here, customer segmentation is a process of dividing customers into group based on common characteristics so that the companies can market each group effectively and appropriately. Basically this is used by various big companies to market the people on the basis of where they belong from, what season is going on their country, and many more things related to that. For example, a person who is constantly buying electronic thing, he has been kept in that category of the people who is very interested on the electronic goods and is marked accordingly to a label which is interested in electronic good. Another person who is buying a large amount of furniture or is buying a new house and needs furniture for that, he'll be continuously visiting the sites or the pages which are related to furniture tag, and he'll be marked according to that list who is interested in furniture. And based on this, whenever he will be going, he will be seeing that related to furniture ads. So this is a part of unsupervised learning. Now customer segmentation is an example of unsupervised learning task, since we create cluster of customer based on various attributes like demographic and psychographic information. This help us to target customer with what they really want. It is basically nothing like we have labeled the customer, or we have divided the cluster or the group of customer on the basis of certain characters. Now defining what unsupervised learning is: the learning method which uses the technique of grouping, clustering, predicting the unlabeled data on the basics of its physical characteristic is known as unsupervised learning. You can see here we have different fruits, two apples, two bananas, and two mangoes. We have given that into a model, and algorithm is there to work on it. That data is then processed, and then we have got the cluster of three groups, which is one of the apples, one of the bananas, and one is of the mangoes. Here the model sees different features which are there, like for apple you can see it is in round shape with a petal on the top. Banana is in a long shape, and the mango is bigger than apple. So these three models are three different groups are made accordingly. Another use case of this is that 75% of the content you watch on Netflix is from recommendation. For example, a person watching too many of the comedy sketches which are present on Netflix will be getting more and more suggestion from the tags which are related to comedy sketches only. So that is also another use case for unsupervised learning. Now, next use case for that is training a self-driving car. We'll seeing it belongs basically belongs to the reinforcement learning. Now, what reinforcement learning basically is? Reinforcement learning, we can say that if there is a person, we have to train them. He will be learning from his experiences. If there is a baby who has to learn if the fire is hot or the water is cold, if he will be touching the fire or he will be touching the thing which is hot, he will be getting a sensation in his brain that he has not to touch the thing and it can harm it. So from the next time when he will be seeing the same thing, he will be getting an idea that he has to not to touch that hot thing because that can harm him. So as a humans learn, it is basically similar to that learning from your old experiences. You can see here that there is a closed board and the car is walking. A car will be seeing that the board is closed. If it will not be stopping, it will be getting stuck with the board, and there are points which are basically deducted for every bad thing which is done by a model, and then it will be learning from that points that acha that I have stuck with that board and my points are deducted, so I have not to do that again and I'll be taking the another rod. Basically it works in the six processes, which is observe the things, select action, usage policy, take an action for which you will be getting a reward or a penalty. If there is a reward, then it is well and good. If there is a penalty, update the policy and iterate the same process. Now what reinforcement learning is, it is a hit and trial method of learning. Actions on the basis of experience, machine gets a reward or a penalty for each action. Basically, as I have told you that like humans learn, they get a sensation in the brain about whatever things are happening in the environment, or this is good for not, or this is bad for them. They learn from them and then they are careful next time practicing the same thing. This is same with the case of reinforcement learning. Another use case is that making a robot learn. I have given you the same example for the human, like what a human learns. When a robot sees fire, he'll go to the fire directly, he will deduct 50 points. Next time when he will be seeing the fire, he will be getting an idea that fire is a bad, and he has to avoid that next time. So yeah, that is basically the case of reinforcement learning. Another example of reinforcement learning is, this is the one of the best example which Elon Musk is using. You can see that Tesla works on the basis of these. There are many more things which are going in backend, but it is also one of the thing which is there, like Tesla cars are trained on the basis of reinforcement model. If a Tesla is working, and it has also different sensors also, but generally if a Tesla is working, it has already been trained on that if there is a pole, it has to avoid that pole. If it will not be avoiding that pole, it will be deducting some of the point. So yeah, this is the case which reinforcement learning tells us. Another example which we can another model which we can is there was the semi supervised learning model. It is basically based on two models, combined model, which is the a non-supervised learning and the reinforcement learning. It is combination of both, where some of the information or the clusters of group are based on the clustering type of data, and on the basis of that reinforcement learning, these both are combined to make the semi supervised model. Now what are the steps which are basically there, or which are basically involved in machine learning? The first and the most important step is there, which is data collection. If you have a good quality data, don't focus on the quantity. You will be needing quantity if you will be get you want to get the accuracy in much more quality. You have to practice the data collection thing to get the data. After you have practiced the data collection thing, you have to work on the data analysis. You have to we can say that analyze the data through different libraries which are there to analyze the data, making graphs from it, different bar charts from it, heat charts from it, which are different formations of data, to look to for you to look which of the things are connected with each other. For example, there are two columns in a data, height and age. You can see by analyzing that data how these both are connected with each other. This helps the people who are practicing machine learning to get insights about the data which they generally ignore while seeing the data. So through this they can get a better view at data which they have collected while in the data collection phase. Now the third step which is there is data wrangling or feature engineering. This is the step through which we can increase the accuracy, or we can have our model predict or get the values effectively in the last. It is basically, if we have data we have collected, generally the data which we get in the real world lack some of the fields, or some of the fields are not really important for us to practice or for us to see. So we generally tend to ignore this field or remove this field. If there is null values, or the values are absent in some of the columns or some of the rows, then there are three things which can be done. Either we remove the full row or full column, either we can remove only the column or the row which are having one null value, and the third thing which is there, which is mostly used, is taking the mean from the values up and down from it or from the data, and then filling that empty column or the empty row with that mean which we have got. So this is also an important step for getting your model to perform in a very good manner. Next comes the step is of training and testing the algorithm. Hey, this is the step where you apply various different machine learning algorithms. You process the data which you have collected, you split it into two parts, which is one of the training and one of the testing. You train your model on the training data. After the training is complete, you see what the accuracy you are getting or what the things you are getting. After the training is completed, you then put the testing one column of the testing data to get the output for the second column. You generally take the testing data into it and find a predicting value from it, which is basically the predicted result which the model gave on the basis of training it has performed. After that, you have got the predicted data or the predicted column. You compare that with the pre-existing column or pre-existing row in the testing data set. After that comparing, there are various different functions which are offered. You can check the accuracy, how accurate the data is. There is one thing, confusion matrix, which generally provides you the amount of correct prediction which are there. It provides you the data in the form of matrix, and it shows that how many correct values they are predicted and how many wrong values are predicted. This is basically the training and testing part. Next is the model selection. The training and testing part which is there is based on the model which we have selected. For example, as I have already told you that if we want to predict the price of the data, or if we want to predict the different columns or the different categories or cluster, if we want the house prediction, then we will generally be going for linear regression, SVM, which is support vector machining, and LR linear regression model, and various model related to that. But if we want to go to the clustering algorithm, which we want to cluster the data into certain groups or certain categories, then we will be going for random forest or for the logistic regression. One, logistic regression and linear regression are basically two algorithms which are the basic algorithm, and the one practicing machine learning should always start with both of them. After, firstly, we should learn these algorithm. I'll be talking about that in further in detail, but giving you a basic that learning the algorithm, practicing them on the basic data set, and then practicing it more and more, and then going to various different hard algorithm which are there. Now next thing is the hyperparameter tuning. If we have trained the model, we have tested the result, and we are getting an accuracy of around 50%, 60%, then we can know that our model selection is correct. Generally we try various 2 to 3 models to see if we are getting accuracy on all of them, or is it the particular model which is not performing accurate. If we find that our model is correct, then we generally go to the data, we tune its hyperparameter. Like if there are 4 columns which are there to be provided in the testing data, we generally try to ignore the less effective column which has no effect or very least effect on the data set. After that tuning of that column or tuning of the data set which we are having, we go to the step 4 again, then step 5, and then step 6. These steps are in continuation until and unless we have gotten high accuracy and the high predicted data in the correct form. Once the thing or the accuracy which we have got is up to the mark or up to the level which we want, we then generally send the model in the prediction phase or the deployment phase. This is generally deployed on servers online, like different server provided by Google, Amazon, or the company which are having their private servers. These are deployed for the people to be used, or for the different thing which they are made for. Now, people are generally confused on the fact that which algorithm to be used. Either they have to use the regression algorithm for the data set, or classification algorithm, or clustering algorithm, or anomaly detection algorithm. So we'll be seeing which algorithm to use in which factor. Firstly, looking at the regression algorithm. These are to be used when the data is itself is predicted. Basically, which we can see that we have generally an line y equals to mx plus c. We have seen that if some points are falling in the path of the line, then if we extend the line to a very long, then we can predict the data which are coming on the line, which are falling on the line. So yeah, that is an example of linear regression algorithm. What we can predict from it, we can predict market value of the house. For example, there is an house who has two rooms, a bathroom and one hall, and it cost $6,000. So we can see that what will be the price of an house having three rooms, one bathroom, one bedroom, one hall. Like this, we can predict that from linear regression algorithm. Now, seeing what all algorithm falls under the linear regression algorithm category. So first algorithm which falls under this category is a linear regression. The second one is logistic regression. It is basically both for uh, predicting the data and for regression of the data. The third one is the polynomial regression. The fourth one is decision tree cart, and fifth one is random forest. There are much more algorithm, but these are the basic ones which are generally found under the regression algorithm category. The next one which is there is the classification algorithm. These are used for grouping clustering of the dataset. For example, there we have seen as how people are to be clustered in different forms for targeting the ads in different sector. We can use classification algorithm. We can read why we use categories predicted using the data. We predict different categories on the basis of dataset which we are providing. We can use these where we have to predict if a person is a male or female, if the spam is mail is a spam mail or a non-spam mail. So in that case, basically classification algorithms are used. For example, which are all algorithms comes under the category of classification algorithm. Firstly, we have decision tree algorithm. Secondly, logistic regression algorithm, naive bayes, KNN, which stands for uh, we'll see that later. KNN, random forest, and SVM. So yeah, that is. Now we'll be seeing what all algorithm fall under the clustering algorithm category. Why we use clustering algorithm? These algorithm are generally used for the groups data based on some condition. For example, this can be used for seeing which type of house lies in this segment or what type of customer buys this product. So we basically use clustering algorithm there. For example of algorithm which falls under the clustering category is that K means clustering, C means clustering, hierarchical clustering, and a priori algorithm. These are the algorithm which falls under the clustering algorithm category. Now looking at the anomaly detection algorithm, these are used for identifying usual data points. We can use these in cases of if there are frauds in the transaction or not. Basically these are used by bank or different sector to predict if the things are being frauded or not, if the things are correct or not. So basically these are used there. Is someone trying to hack or not, hack our network or not, on the basis of requests which we are getting. For example, there is a system or a server which we are running on our it is a private server. On the basis of the request which we are getting, we server basically serve the request on the basis of request it is getting. So if a person is trying to hack into a server, you will be getting a continuous same type of request again and again. On the basis of that, we can see if that request is harmful or dangerous for a server or a network. Different algorithms which fall under this category is time series algorithm, K nearest neighbor algorithm. K means clustering algorithm, C means clustering algorithm. What are the common use libraries or the libraries which people start with? The first one which is there is a Matplotlib. It is used for creating basic visualizations like bar chart, scatter plot, line chart, histogram, pie chart, box plot, heat map, and many more. Now the second one is NumPy. It stands for numerical Python and provides an abundance of useful features for operation on an array. And an array is basically multi-dimensional array and matrices in Python. The next one is Pandas. It is used for data wrangling and data manipulation, aggregation and visualization. Next one is scikit-learn, which is open source, simple and efficient, mostly used for inbuilt machine learning algorithm. And final one is Seaborn, used for creating attractive and informative statistical graphics. There are many more like TensorFlow, Keras, PyTorch, but these are some of the advanced one. The basic one I have told you, these are the five basic libraries which a beginner should start with. And if you are slowly progressing in the field of machine learning, you can then switch to TensorFlow, which is it's in itself is a very big and very diverse library, and it provides various different features for a person to practice machine learning or data science, deep learning. And yeah, now one of the most important question, or the people which who want to get into machine learning basically search how they can get into machine learning. What should they start with? Should they learn TensorFlow in beginning, or should they learn NumPy? Should they learn Seaborn? When I was starting with machine learning, I was also very much confused. I have took up certain courses on Coursera, different sites, Udacity, and one more I have taken Idionics. I have taken one more course about getting started with machine learning. But yeah, those courses generally don't teach you anything which is related to how you can start or the basics of machine learning. These are the course which cover in a four week video, they can cover complete machine learning, and you will be ending up learning nothing. So from a person who has himself started into machine learning, I'll be providing you how high I have started into machine learning. First thing which you should get is you should get good with the basics. Now what I am trying to say with that this point is that if you are a person who is having Java as his primary language, generally different languages except for Python are very difficult to start with machine learning. I would suggest beginners, if you haven't started with machine learning, to learn Python and get good into it. I am practicing Python from past 1.5 years, so I am pretty good with concept. I have done various different projects in it also, so I was good with the concepts of Python. I would recommend that for beginner, if you haven't started yet, get good with the basics, learn the basics of Python, how things work in Python. Once you are good with the basics, next you have to deal with the arrays. As generally in data science, or we can say machine learning, artificial intelligence, everything is converted into arrays or multi-dimensional arrays. If you are having your data, it will be in the basic in the form of either pandas data frame or in the form of numpy array. If you are having an image, your model will be converting that image in the form of multi-dimensional array, and that will be used for prediction or the purpose of training of the data. So the most basic thing which you should learn is to learn about the arrays, to deal with the array, how you will be changing different values in array. For that, library which is offered by Python is a numpy library. Get good with this library, learn the basics of it, where to use which function, which method are to be used, which function has parentheses, which method does not have parentheses. Learn about it, get good about it. Next you can learn how to get dealing with the data. For that, Pandas is another library which is offered by Python. This basically teaches you how you can deal with the data set which are available. For example, you generally get your data in the form of different CSV file, text file, PDF files, or the SQLite database. You will be learning how to deal with all of them. You will be learning about various different things, reading from data, writing to data. I have also made different videos on my YouTube channel. You can check that out. It is with the name of Harsh Kumar Khatri. I'll be putting my full series in that. You can learn various different things from that. Uh, from Pandas, you will be learning to deal with the data frame, converting your data into data frame, seeing the data, changing the values of data, filling the null values. You will learning these many things with Pandas. Now once you are good with the how to deal with array and how to deal with the data which is provided to you for training, and you need to know how you can visualize that data. This is step is generally ignored or replaced by the people who are practicing machine learning in the beginner phase. But we should not ignore this process, because it is very important to get the more and more knowledge of the data, what the data want to say to us. For example, if there are columns which have certain relation, you won't be getting any idea about those relationships general simply looking at the data. For getting a good knowledge of the thing what the data wants to say, or the relation which the data has among its column, you generally need to we can say that visualize the data. And for that, Python itself offers another library. Two libraries are there, you can use any of them. The first one is the Matplotlib library. It basically provide you various different features from plotting to visualizing. You can create bar plots or the scatter plots, heat plot. The same features are provided by another library, which is a Seaborn library. Seaborn is another very good library. I started with Matplotlib, but there are certain things which you can't do in Matplotlib, or you have to write a code for more than 2 to 3 lines, which can be easily done through Seaborn in generally one line of the code or 2 line of code. So I switched to Seaborn after learning Matplotlib. So I would suggest if you are beginning with visualizing, so you should choose Seaborn first, and after learning Seaborn, if you want to explore more, you can explore Matplotlib. Chances for you replacing are always there. Now, once you are good with all the three, dealing with array, dealing with data, and learning how to visualize the data, now you have to starting with the library or the framework which are there. Now people who are beginners start with the scikit-learn library or different libraries which are there, who are excuse me, the libraries which are various libraries which are offering different algorithms in it. I started with scikit-learn. At first, while I was doing certain courses, I started with TensorFlow, but when 1 or 2 weeks passed, I got to know that TensorFlow was very hard to learn, and also my computer also didn't had such a specification where I can practice it on my PC. I had to go to Google Code Lab or different services provided by Azure for practicing TensorFlow. So I thought of switching to scikit-learn, which is a very good library for beginners. You can start with that. It provides you with almost all the learning algorithm. You can train your model and predict data from that very easily. If once you are good with scikit-learn, you can replace that with TensorFlow, because TensorFlow is in demand, and it is predicted that it will be in demand, and it is currently also in demand. Google is investing on the engineers who are having TensorFlow as their highest priority, or learn who know TensorFlow very good. So yeah, I have also switched to TensorFlow past week only, and I'm still learning and beginner in TensorFlow. I generally know scikit-learn in at intermediate level, and keep practicing different questions or different data set which are there. Now the final thing which is there is that it is always said that you can't learn programming by only reading the facts or reading the code which are there in the books, or which are provided online, or watching videos. You have to practice, or you have to get your hands dirty, as Andrew said in the starting video. For practicing or getting good with AI, you generally have to get your hands dirty. Once you get your hands dirty, practice the code, practice the real world data sets, learn about data set, practice different data set to predict different values. You will be getting that things fed in your mind, and you will be, after seeing the data set, you will be easily getting to know which algorithm you have to apply there, or which visualization you will be using there, how to convert the data values, or how to change the values. Once you have learned that too, the next thing comes. If you want to go in some specialization, or you want to participate in some of the competition, you can always go to the kaggle.com. It is a very good site for getting your data set and practicing, or for online challenges also. Kaggle generally has 2 to 3 challenges every month, where you can participate and get badges and certificates according to the results which are being announced there. Many people go there, and after you get very good with Kaggle, you generally are titled with Grandmaster on the Kaggle side, which is a very big title for the people who are practicing machine learning, data science, and stuff like that. So yeah, that is it with how you can get into machine learning. Now, thank you. This was all for the session. If any one of you have any doubt, you can turn your mic on, or you can type that into the chat. I would be happy to help. Don't hesitate. If you have any doubt, you can directly ask that, or you can ask that in the chat also, if you want. So I think if there are no more questions, I would like to tell you that after this session, you will be sent a mail regarding the feedback. You can basically tell how the session was, what you learned from it. Apart from that, You can always connect with me on the various on the platform which was there in the event form that was given on the Eventbrite page. You can connect with me if you want any information about how you can get started with machine learning, how I have started, although I have told you, but there are many more things, or the things which I have faced while learning machine learning. You can directly message me on the LinkedIn. We can connect there, and we can make each other learn various different things in the phase of machine learning. Also, there is one more thing that for the people who will be filling the feedback form, they will be getting 50% off Coursera coupons for after filling the form. Once you have filled the form, you will be receiving that coupons after that. Now I have got a question in the chat which says what is the difference between ML and deep learning. Now, although I have to cover that in slide, but covering it again, machine learning is a bigger set, and deep learning is a subset of that. Machine learning generally is a part of artificial intelligence where we deal with the data in various different form to get the knowledge by applying the algorithm. Like different algorithm are there, but deep learning is another sector which is a part of machine learning where we deal with data, but by applying neural networks there. uh, uh, Speaking more about that, neural network is basically based on neurons, which are the different sectors. We have different neurons for the different inputs, we have different neurons for different outputs, and in the middle we have different hidden layer. And the amount of neurons in that hidden layer are also depending upon us. If we change the value of that neurons, we will be getting different predicted value, the different accuracies will be there. So yeah, this is basically the difference between ML and deep learning. Basically, if you want to start with machine learning, you can generally start with the algorithm, basic algorithm which are there. Never ever start with going directly into neural networks. Once you have got your hands dirty or learned basics about the we can say different algorithm, then you can switch to neural networks as it is more accurate and it is being practiced nowadays. Another question is that do we have overfitting problem in deep learning that we have in machine learning? Yeah, there may be a cases if you are providing the data which is not yet accurate, or which is not good for the model network model to learn with. You can face the problem of overfitting. Another question from Mohit Yadav. He says, which skill should I learn before artificial intelligence? Mohit, there is nothing like which skill should you learn. If you want to get into artificial intelligence, you should always start with first getting the basics of a language which you want. For example, for me, I have started with Python. I have covered its basics, solved many hundreds, about 100 or 150 questions continuously in Python to get the basic knowledge of the concept which are there in Python. Once I have solved those questions and I have good knowledge of Python, I then switched to NumPy. I started with NumPy, solved NumPy questions, or learned about its basics. You will always find videos related to that on YouTube, like one video teaching you about NumPy, and you can complete NumPy in around 1 to 2 hours if you sit on one go. After NumPy, I have started with Pandas, after which I completed Matplotlib and then switched to Seaborn, and after which I started with scikit-learn. So yeah, if you want to start with AI, you have to first choose a language, then keep on doing things. And basically, AI is a complete bucket which has different parts in it, like machine learning, deep learning, data scientist. If you want to go into the data science fields, you have to get strong with the concepts of NumPy and Pandas, and get your hands dirty much more into the field of handling the data. If you just want to go into the deep learning phase, then you have to get very good with the neural networks. If you want to get generally in general machine learning field, then you want to get a very good knowledge about how you can apply various different models, like there, if you are going for a machine learning engineer in Uber, then you are generally given a use case. For example, there is a use case that 100 people have ordered a particular thing and 150 people have ordered a particular thing. Now you have to tell which algorithm you will use, how will you will use this, and how you will deal with the data. So basically the main question which arises there is which algorithm we will be using. This is basically the first question. So this is the thing, how you can get into data, AI, artificial intelligence. So next thing which is asked is, do you need a degree or certificate uh, can do well? Do companies look for a CS degree if they want to hire you as AI project? You in AI projects, yeah. So you don't need a degree for getting started with AI. Generally, you have seen on your Instagram or Twitter, you generally people post that Google, Microsoft, and many various big companies generally don't require a degree for a person to be getting started as their working professional. End use company itself, I guess, don't require degrees for that. And the certificates are also not a big thing in the market. You can easily get certificate completing few courses which are available, but the basic thing which lies is with your knowledge. If you are getting started with a person, or you want to get into a company which has AI has its most top responsibility, or is working towards the beneficial of artificial intelligence, they will generally be looking at what you know, how you have practiced it, how much knowledge you have. They will generally try to get most out of you in the interview rounds or in the practicing rounds, so that you can show what you have learned in your journey of AI. As I have told you the example of Uber, they generally in the interview round try to get out what you learn, what algorithm you can apply, what things you can show them. For example of Uber, saying much more about that, there are many algorithms which can be applied on that data set, but there will be one algorithm which will be providing at most accuracy, like you can get approx 99% or 100% accuracy with that. So they want to bring that out of you, and in how much time you can solve that problem, or how much time you will be getting that accurate data. So they want to see that they generally don't ask you for a degree or for a certification once they are confident enough that you know much more. Like if you are a Kaggle grandmaster, or you have got a title of grandmaster on Kaggle, and you showcase your skill on Kaggle, then companies who are practicing AI or ML, they will directly be contacting you and willing to be hiring you, because they know that you have shown your skill already in the Kaggle, and people are appraising you there. So they generally don't ask you for a certification or a degree while taking you on board. Hope I have answered that correctly. Are there any more questions? You're welcome. So I guess if there are no more questions, so we can close this session. Also, I would request you all to fill the form which will be sent to you, so that you will be getting the 50% off Coursera coupons, which are beneficial for you to get different courses which are provided to you free of cost. So yeah, thank you for the being a lovely audience, and I'll close the session.